Now, to deal with this differential equation, e to power t dx dt is equal to sin t, we separate variables. So we shall have dx is equal to 1 out of e power t sin t. That's an exponential. So dt. So we go ahead to rewrite the exponential to e power negative t sin t dt. After there, we'll go ahead to integrate on both sides. So when you integrate on both sides, we have x this side is equal to e of negative t sin t dt. Now the next thing is to deal with this integral that is remaining. So we pull it out, so it goes for by parts. So we first deal with it alone and then you substitute it back. So consider, so when we pull it alone, it's always better you pull it out and then you deal with it alone. So if you look at using the eyelet, we are to let u and also to let dv dt in this case. So let us first underline. So in first underline to create space this side, we shall have our u as sin t. So we are using the eyelet. So we have our, that is inverse, logarithmic, algebraic, trigonometric, and exponential. So we have our u as sin t, and then our dv dt is actually e of negative t. So when you differentiate du dt, you get cos of t, and then when you integrate, you get negative e of negative t. So putting it back, so we have our negative e of negative t sin dt is equal to, so we substitute back. When we substitute back, we shall have negative e of negative t sin of t, then minus integral. So we substitute in the remaining, the v. So we shall have negative e of negative t, then cos of t dt. So it has to be dt. So simplification. So we have a negative e of negative t, this is simplifying, plus the integral of e of negative t cos t dt. But remember, integral of that one is goes for by part. Integral of e negative t cos t goes for by parts. So we write u as cos of t, and then our dv dt, dv dt. So we differentiate. This is negative sin t, and then we have our v as negative e of negative t. So putting them back, we shall have e of negative t sin t, then minus gives us a plus. So remember, we have a plus there, so here we are substituting in. So we have negative e of negative t cos t, then minus, we put there the negative, and negative gives us a positive. So we have e of negative t sin t dt. So when we simplify, we realize that our e of negative t sine t dt will equal to those ones we can pull out a common factor, which is negative e of negative t into, so we have sine t plus cos t, then minus integral e of negative t sine t dt. So we can collect like terms together to have this as 2 integral of e negative t sine t dt is equal to negative e of negative t sine t plus cos t. So when we can divide throughout by 2, dividing throughout by 2, we have our integral of e of negative t sine t dt is equal to negative half e of negative t into sine t plus cos t. So we add on the plus c, the integral, the constant of integration. We have to add it there. So therefore, when we take it back, therefore we shall have from our integral, which was x is equal to the integral of e of negative t sine t dt. So we shall have x is equal to, putting it back, we have negative half e of negative t sine of t plus cos of t, and then plus c. Therefore, you have finished solving it. Please consider subscribing. If you have understood, share it with your friend. We meet in the next. Thank you.